All right, and we're live. How's it going, everyone? If you're just tuning in, so today we're going to be talking about the Compose compiler some more. I'm going to be working on a new feature that I'm basically just doing on stream. So this will be the third stream that I've been working on this, and it's called Stability, Inference, and Propagation. So the work that we have up so far, I've put in this CL, but it's nowhere near complete. This is going to be a pretty long project. And I'll just add some resources here in the stream, just for those who haven't had like the benefit of the context of the previous streams. In the first stream, which is up here on YouTube, I spent probably like the first hour of this stream kind of talking about what the feature is and like what the motivations are and how we're going to go about it and some of the design and things like that. So I'll paste that here. And also, let's see, let's try and get the I'll also paste a link to the code in progress in case anyone wants to check that out. We'll just go ahead and jump into it. You know, let me know if anything's off with the stream or anything like that. Goodman asks, how does daily work on Compose look like? Well, you're about to see, I guess. That's what this stream will be about. So, happy Wednesday, Joe NRV. Okay. Oh, also for some people that have asked, I've been trying to look into how to get the playlist of the music that I have going here. I honestly haven't had much luck yet, but I did find a Twitch extension, which I've enabled. So I think if you like, there should be like some button or something that shows like Pretzel Rocks, and I think it'll have, and let me know if it doesn't, but I think it'll have like the current playing song and some stuff in the queue and stuff like that. So anyway, if you're interested in the music, check that out. You know, also check out the service Pretzel Rocks. It's actually pretty cool. It's like free music. A nice like instrumental chill stuff too. So okay, last time I'm trying to remember exactly where we were, but we had gotten the main Compose transform working with the multiple, or like basically the new 3-bit metadata encoding in the change parameter, and I think I convinced myself that's sort of working basically as intended, and so now what we kind of need to figure out is like how to like if you see here, let me pull up the test. So in these tests, we should be in calls to other composable functions. So like here's an example. We should be generating some expressions here that might be like a bit complicated, or like they might have the synthetic field that we're generating in the class stability transformer. But the problem is that this is a synthetic field, so we don't really like actually generating the code to call it might be kind of non-trivial. So that'll be sort of a challenge. And in the meantime, one of the things that I've looked into was we've got like we talked about this last time, but we want to do the analysis of whether or not a class is stable or not. We want to do that on the front end of the compiler, so that like potentially so that we can access that information from the IDE if we need to. And I have some ideas for how to do that we didn't go into last time, but that might be like the next thing that we do here. So this is the call checker. And we have this type resolution interceptor extension, which we're already using for @composable in a few ways. I think we might want to use this extension point to add a stable annotation onto a given type. Maybe. I don't know. We're gonna play around with it. So let's figure out how we might do that. I'm gonna try and build a test that will exercise the front end. Where do we have? We've got some tests here. So this is a diagnostic test. Which isn't really quite what we want, but I'm gonna start from here to play around with it. Yeah, let's try this. So we'll duplicate this class and call it stability inference tests. Hello Leland, I've been playing with Flutter lately and I love how fast hot reload is. Will preview be as good in the future? Good question. So there are definitely some things that we're working on that should give us like really fast hot reload like capabilities, but potentially not in all cases. And we're still kind of searching around avenues to make certain parts of the pipeline faster. There's kind of like, if you look at the overall build pipeline, there's like a lot of things that could be improved, and we're trying to be methodic about attacking each one. And yeah, so basically I think it's safe to say that at the end of the day we're going to be way better than we are right now, but also, you know, Flutter uses the Dart VM and has like just a lot of ability to own the entire pipeline in ways that we don't. and the Dart VM is like sort of optimized for this. So Flutter's hot reload is quite good, and I'm not sure that will ever be as good. It'd be cool to see your desk setup at some point if you're happy to share. Yeah. I mean, so I could do like a full video or something on it. If you're interested, I don't know. There's let me see here. Yeah, so you can see this like this camera here, but that doesn't really give you a great view. So maybe sometime I'll do that. But there is some kind of interesting things that I've done for the stream specifically that are, I don't know, kind of neat. And today I'm using this new like big clunky Microsoft ergonomic keyboard, which I'm just using because the keyboard's been killing me the last couple days with I don't know, this new dock and like the Bluetooth and stuff. It's just not working. Would be fun to see you do a code review for a composed patch. Imagine it's a big part of your day, but I haven't seen it on stream. Yeah, we could do that sometime. I'm trying to, yeah, I mean, I don't have any problem with that. I feel like it's not quite as interesting content as this, but I don't know if people think that they would enjoy that, then we could do that. So okay, test basic stability inference. This is, I actually have an idea for this test that I think could be kind of cool. Let me see where I did this. I have this sort of like here. Yeah, so I wrote these tests at one point, which allow you to write like some compose code. And basically I can sort of annotate in certain places, like whether or not, like in this case, it's supposed to indicate that like this is a composable call versus like a normal call. And like, so here it's like normal. I think maybe I'll do something similar where like we'll be able to say that it's like you know, stable or unstable or like uncertain or something. I think that could be a pretty useful way to test this. So I might do something like that. Maybe steal some of the utilities in here. Figure out what this does. So so this uses JVM resolve util analyze, and then I basically parse. I grab the carets, which is like the tags or whatever, and then I can get a given like call at the offset or something. This seems like a pretty good idea actually, because instead of just getting the resolved call, I can just get the type at that offset and then assert on that. So I think I'm gonna try this. Let's do something like this. We'll just grab this code. I don't think I'll actually need this, but just in case. I'm not sure if we need to do this whole like setup. Yeah, it's not doing anything right now. Okay, so let's say assert stability, something like that. And then let's like write a test that we like a test that we would want to be able to write. Let me read some comments here. So I was just thinking about it because I saw an interesting CL today that improves scroll performance for lazy column. Yeah. I think it's a good idea. Let me know if anyone else thinks they would be like into that. I mean, it might be more interesting for certain CLs than others, right? So I mean, I think a lot of the stuff that I end up reviewing, it might not be all that interesting to you. So like maybe, I don't know, maybe people can like ask me about certain CLs or something. I don't know. I'm not sure the right way to do that. Okay, so we want to be able to write a test that's like kind of like this, where like I'd be able to say, like write a class like this that's like obviously stable, right? And then I might be able to just say, okay, so this is stable. And then I could write a class that's obviously not. And this is indicated as unstable. And then like perhaps more interesting is I could have like a give an example here. So equals if I did this, and then if I wrote a function like identity, and so like I mean this is like maybe a silly function to write at the moment, but like this could be marked as stable, which is like a thing you can do right now. And if I did that, then the neat thing is I could do something like this. So I could do identity of foo. Or actually, this wouldn't even need to be. Okay, so I mean that gets into like some more interesting stuff, but let's actually not even worry about that right now. So like let's just say I had this identity function, and so it's gonna have some like this expression here is gonna have some type, and what we want to be able to assert is that like this expression has a stable type, so that would be pretty neat. And so we should be able to do that, and then also this. And for instance, if this was something like that, identity. And so this wouldn't be stable or unstable. This would be like uncertain or something, which is kind of interesting. So this is sort of the type of test I want to be able to write. And so let's try and make that happen. And then this will exercise some code that we'll write in a bit to actually indicate whether a given expression or whatever is stable or not. So we're gonna extract the carrots, which works this way, and that's probably not going to change. We need to change the pattern though. So this will be stable, unstable, or uncertain. Maybe we'll just call it unknown. Okay. So that gives us our carrots. And so this gives us the string of like stable, unstable, or unknown, and then the position in the overall string. Yeah, we like keep track of the offsets and stuff. Okay, cool. Let's see, how's it going, Dev Souza? Okay, so when we have all of these positions, we're not going to get the resolved call. We're just interested in like the type at that point. So we might do something similar to this though. So I think maybe we'll just call this get stability at offset. And then we had this like type stability class. I'm not sure. I think this is kind of what we wanted. Yeah, stable, unstable, unknown. Okay. Hi, Nicholas. Thanks for joining in. Sky Color says, I just joined. Are these tests for the compiler directly? Yeah, so these are tests that I'm writing for a new feature that I'm working on called Stable Inference. And if you scroll up the chat a little bit, you might see some links to go and find out a bit more about like the actual feature that we're building and specifically like the design goals and things like that. So yeah, that's what we're doing at the moment. And I'm trying to build like a test kind of fixture that allows me to write things like this that'll be just really conducive to the type of logic that we're going to be writing. So stability, so that'll give us our stability here, and all types. Okay, so basically now we have we probably don't really want to call this call type. We want to stability string, and basically this ought to match that, or else it's like a problem. So let's try this, and we're gonna have unstable. Let's just say stable, unstable, and unknown. deal with that in a second. So then if we're in the else case, then we like wrote our test wrong. And then here we want to say, okay, so if it's stable, then basically stability should equal, I'm going to say assert equals, so this has, why did I not find that? Okay, so expected and then actual. So we expect type stability stable, and we got stability. Then I'm going to add a message here. So expected stable found stability, and then I'm just going to pass like the index index offset. Let's see, for marker of index. Okay. Oh, and the message goes first. So we're just going to write that like 3 times. And then here we expected unstable, stable, and unknown. Okay. Hey Tutor, how's it going? I do not get the explanation in compiler episode 1 about stability. This will improve what? Performance? Yes, so this is it. This is about performance. Basically, there are optimizations that Compose can make, but only if the given type of something follows the contract of stable. And the problem is that like we don't want there's like 2 things that we don't want. We don't want people like all around the ecosystem annotating everything with that stable just because it's like the go fast button or whatever. But we also don't want to like make certain optimizations that are unsafe. Like if we don't really understand that the type is going to obey this contract. And yeah, I mean that's kind of the main thing, right? But this is it's a compiler optimization, and so this is about performance for sure. Okay. So basically, if this returns null, then we kind of need to error out in a different way, and just basically say like couldn't determine stability for this index, and yeah, expected stability string. Hey Evian, how's it going? Good to see you in here again. Okay, so we don't need that anymore. This comment doesn't make any sense. So now we need to get the stability. I think we can just do something like that. And this is going to return type stability. And probably what we'll do here is like something similar where you know, there are certain like element types that we can sort of ask the stability of, and other ones that we can't. And so we'll if we're at one that we can't, we'll just kind of bubble up, and then at some point we'll return null if we think there's like nothing else that we can reasonably do. The sound alert, is it about the thing where you forget to switch to Android Studio? Yeah, so I have like a sound alert extension added, which I'm honestly not sure if it's working. If you want to try it, you can, and then I'll let you know if I can hear it. Last stream I wasn't able to hear it, but I'll be adding some other noises in there, I guess, which will just be kind of interesting. But like the idea is, okay, so Iretzi played the womp sound, but I couldn't hear it, which is a bummer. I don't know. Actually, let me try and change something here. Yeah, so all of you heard it, but what I hear in my headphones is annoyingly different than everything you hear. I just changed something though, so I am curious if you play it again, if I hear it now. So if someone wants to like help me out with like configuring my stream, because I feel very inept whenever I'm trying to configure some of these things. Hopefully the audio is set up well today. I tweaked some things about that, but okay, I heard it that time, so I think I fixed that part at least. We should probably I'm just gonna save this so I can set a debugger statement there, but I think in like some cases we kind of know what we want to do. So let's say if we're like a class, then we should be like saving somewhere the stability of the class. Uh-oh. Now we've got like spammers in the channel. Twitch spam. Yeah, I'm gonna need to start moderating or something. Okay. I don't actually want to return null here. Well, I mean, actually, we'll kind of play around with it. Sign of popularity. Yeah, maybe. Okay, so we've got this test kind of set up, but obviously it's gonna fail miserably right now. So let's try and let's see. I'm gonna do a few things here. I want to create. I'm gonna create a class kind of like this. Let's call it stability inferencer. Sure. Okay, so we're gonna be a call checker. I think there's like a declaration checker which I want to implement, which will probably be the more important one. I'm actually gonna ignore those for now. So let's just do a declaration checker. And then I probably need to do something like this. Okay, let's write something like really dumb here. So like when declaration is KT class, otherwise do nothing, and if declaration.name identify, it's just a string. So let's just say if it's foo, which is the thing that we had, right? So if it was foo, then it was stable. So it's like without doing anything smart, let's just do that for now. And so then here we're gonna say we're gonna save something on the binding trace, and we're gonna make. Oh, we don't want to report. We want to record, and then we want to create a writable slice. So we've got some of these writable slices. But you can see we've already got some kind of around stability here. I'm not sure if it's better to write the stability on the type itself or the declaration. I mean, I think so. The type is something that we're gonna have. Like, I'm not actually sure if we want to use writable slices here. Like that's kind of an easy way to save metadata, but we actually shouldn't be relying on this in the back end. So we might want to like annotate, but I think we're gonna use this to annotate the type. I think is what we want. So let's just start with this. Element type stability. Not a great name, but this will be a type stability that we can save on any KT element, which is like a part of the parsed like AST basically, if that makes sense to any of you. Okay, and then so the element here is going to be the declaration, and then the value, let's just say, so if it's foo, we're going to mark it as stable. Otherwise, we're going to mark it as unstable. Obviously, this is super incorrect, but this will kind of let us know that our pipeline is sort of working. I'll be using those, so keep that. So at this point, I'm gonna copy this test because this is kind of the test that we want, but I'm gonna just have a simpler test so we can potentially have one that passes. So I'm just going to run that, see what happens. Will Android be only limited to Flutter in the future? Definitely not. So I'm not sure why you think that would happen, but definitely not. Maybe it's the performance part. Do you do anything special for incremental builds to work? Do you mean for incremental builds of the compiler to work, or for the Compose compiler plugin to support incremental builds? I think that Compose, with the power of Kotlin multi-platform, we would have in the future a competitor with Flutter with a better approach, in my opinion. Yeah, maybe. Because Kotlin multi-platform works much better with the platforms than React Native and Flutter. I mean, so certainly one key difference that such a solution would have is that Kotlin multi-platform works in the same memory space as the native platforms, and so it's much easier to essentially pass by reference. And this is something that's very, very, very difficult to do in both Flutter and React Native because they have their own virtual machine. Is the element stability like a parent to type stability, or is it on the same level? Skycolor, I'm not sure what you're asking here. Parent to type stability, or is it at the same level? Sorry, yeah, I didn't understand the question. Do the Kotlin compiler plugins even have the notion of incrementality at all? Yeah, so I think the incremental compiles end up getting called with like a partial module fragment, or it's like somehow cached from the previous build, and the plugin itself should operate on given files, and so like if a file changes, then compile the file. And I think at the moment actually we're kind of doing some not very good things in that pipeline that I kind of have on my to-do list to address to make sure that we don't hurt incremental compilation. All right, so the build is still running because I just changed a whole bunch of things like in the actual runtime and everything, and so we have to do a whole rebuild of the entire project, so it's kind of taking a while. Why did you add element stability instead of using the already defined type stability? And oh, I see. The reason was because so this writable slice, I think we just added that last time, so we might end up getting rid of this. I'm not sure, but basically this is like I can then determine the type stability of a type, whereas this I want to save the stability of a given KT element, which is like a piece of the source code basically, and so it could be like an expression or a class or like anything, and so this just gives me more flexibility. Instead of attaching it to a type, I'm now attaching it to like the code itself. So we'll be using it a little bit differently here, and I honestly don't know yet if that's the right way. Like I'm gonna be this code's going to interact with some other code that we'll write in a bit, and as we kind of work on that, we'll figure out like what the right way to store this metadata is going to be. Oh man. Sorry, build. It's gonna take a while for this first build. Did anyone check the like pretzel rocks component like on the side of the screen? It should be somewhere over here. Let me know if that like is useful or anything like that. What's one piece of advice you would give developers that already have been doing development for 1 to 2 years? Let's see. I'm always wary of giving advice off the cuff, because I think sometimes when people are asked to give advice, they like feel high pressure to like say something, and then oftentimes that advice is like actually bad advice because they didn't really think about it. Give me a minute to think about it, and I'll let you know. Okay, so couldn't determine stability, expected stable. Okay, so it ended up returning null, which is like kind of expected. So let's see if it actually like hits this element, which I think it will, but maybe not. So let's see. End of functor. What do you mean that they're on the edge of becoming meteor position? Oh man, more spam. I need to, let me see if I can, okay, I can block certain users, so I'm gonna do that. Eric, sorry, the pretzel rocks component is like it's a Twitch only thing, I think. So sorry. Okay, so the first thing that we get, so yeah, so we're at this leaf PSI element class. I'm surprised that it, so I'm just gonna like comment these things out. Because basically we wanted to get the parent of that, because hopefully eventually we'll have a KT class. They're about to become normal developers instead of junior developers. I see. I don't know. I mean, so here's some advice that I think you can't really go wrong with is like find the really good people, right? Like there's always like these really talented developers in like organizations, and you know, like don't be like annoying, but like try to learn from them as much as you can, and like you know, emulate them. It's always like if you find yourself without a mentor or without someone that like you think you can learn from, try to fix that situation. Like I think I found myself in that situation a few times, and you can always like, you know, build on your own skills and stuff, but I think it's really important to have people that that you can learn from, and yeah, I don't know. There's one thing. Would I quit a job if I were in that position? I mean, not only for that reason, but I think that like you should, like it might be one of the reasons to consider leaving. You know, if I mean that's like a strong statement, but I think that that's reasonable advice. Like you know, do your best to like. This person doesn't necessarily have to be a colleague either. That, you know, it could be a mentor in a different capacity from another source, but I don't know. I think that I think that you can level up much quicker when you have people that are that level already around you. But it's not always possible. So I'm not saying like don't take it as like a blanket statement of you know, like quit your job or something if you don't have this. It's just try to fix that situation. It's worthwhile to try and change that status of your situation. Hello, Forrest Gump. Not so sure about the fictional character from a TV show, but maybe. Okay, so now we have the node, which is a KT class. And so in this case, what we want to do is we want to return the binding context, pose writable slices, element type stability, and in this case we'll pass in the node. All right. So we'll see if this works. This might work now. For how long have I been a developer? Well, I mean, so I started programming like in middle school, kind of, as like a hobby, and I got my first job as a developer in high school, working for like a small machine shop locally, and working on some software for them. And then I went to college, and like at that point, software development, like I kind of viewed as like a hobby, not as like the career I wanted to go down. And so I went to school for math and physics, and as I was in school, I got a job as a software developer to help pay my way through school. And I think like through that by the end of the 4 years, I had like an interesting opportunity to go start this startup with someone, or go to grad school for physics. And it was a really tough choice for me to like decide what I wanted to do. Like if I wanted to go into physics, maybe become a professor and do research and all of this, or if I wanted to go do like the startup thing. And I was really conflicted at the time, and I ended up going down the software route, and I think it was definitely the right call. But like one of the things I really tried to ask myself, like, because I had done some research as an undergraduate, and I think when I was being completely honest with myself, I had to realize that I had more fun like doing my job as a software developer than I did as like doing research. And not that I like hated it or anything like that. It was just that I started to become passionate about software development and less passionate about research. And I was a little bit jaded about some aspects of my physics research as well. But because of that, I sort of decided, okay, let's give this software thing a try, and kind of haven't looked back since. But I graduated college in 2012, and so I've sort of been in like the more professional software engineering space for about 8 years, I guess, a little over 8 years. But I guess I had been writing software for a long time before that, but that's sort of my career as a software developer. All right, so couldn't determine stability. Interesting. It still returned null. Element type stability. Let's see. Kishimao says, being well surrounded is important the first few years. You build some mental models, habits, and a big influence. I've seen companies where they have a shitload of student, junior, individually working on something on their side, and that's horrible. Yeah, it can be. Yeah, if you don't have like the proper like people to like slightly more senior people to kind of guide a project, I think that's important. Where should beginners go to learn the operations of a language? I'm learning assembly. I'm not sure what you mean. Like, so do you mean like the instructions, like assembly instructions? I don't really know. I mean, that depends on what assembly language you're learning, but I think that's not really the typical path these days. I'll take pain into account. What do you think? TDD or BDD? I mean, so it honestly, like, I think people get a little bit too dogmatic about TDD, but I think there are certain cases where it's very useful. But even then, like I mean, for instance, like the very first thing I did when starting working on like this stream today was and like what we're still working on is like building some test infrastructure so that I can actually like exercise this code and figure out what's going on. And for some things that's really important and like also really easy to, it's like the easiest way to actually validate what you're working on, but other times it's not. And so I think it just depends on what you're working on. If the node.parent is the root node, won't then node.parent return null? Yeah, but we've got a while node is not null. So that's sort of the point of that. Okay, so so this thing isn't running, which is our problem. So I didn't do anything to add this to like the project. So we need to do that. I think that happens in here. Yeah, we basically want to do this. So we've got a bunch of these storage component container contributor things, and I'm gonna add this there. Stability inferencer. So that should now cause this to work. The testing pyramid. So like, should you be integration test heavy or unit test heavy? People do get they have strong feels about this for sure. Again, I think this kind of depends on the context. So, like I guess one thing should be, like, the way I look at it is, integration tests survive. So if you have an integration test, it should be, for the most part, very independent of the implementation details of things under you. So you're testing like very large scale behavior, and so those tests are really useful for surviving refactors and essentially verifying that, like, after a refactor, this thing still works. And unit tests, I mean, there's different levels here, but unit tests in general are going to be more likely to not survive refactors. Like, you might change an implementation, and like, depending on what level you're writing the unit test at, like it may not depend on implementation details, but a lot of times it does, or you change the implementation in such a way that the unit test becomes meaningless. And I think both are good to have, depending on like what it is you're testing. So like, if you have like some, really hairy logic, and you want to really just like poke at that logic, that like very contained thing, unit tests are absolutely great for that. And it's good to write, a lot of them to the point where you're confident that if you changed anything, then like this wouldn't break. But I don't know. I guess going back to the question is, like, I don't think it really depends on the project. When you're talking about UI tests, I think that integration, like for like a user-facing application or something, I think integration tests are probably where I'm gonna lean more than anything. But like, I would have little spots of like heavy unit tests on different pieces of like an application that are like critical logic heavy pieces of my app. So that, I don't know, that's how I think about it. So Neil asked, what's this project about? Well, thanks for joining in. We are working on the Compose compiler. I've got this new feature that I'm working on that I call stability inference and propagation. If you go up the chat, there's a link to the first like sort of episode of this series of streams that goes into a lot of detail about like the motivation behind the feature, if you want to check that out. Okay, so we've got this test working now for classes. So like for given class, it's gonna determine that. And to start off, I think that's good enough for me to get started actually making this logic more than something that just checks the name. So that's like the next thing that I want to do. So I'm wondering what the best thing to do here is, but like I mean, one thing that I could do is I could just like run, like to do the analysis here, I could just run a visitor on this class. But I'm not sure that that's the best approach either. But there might be like, you know, the type system might have enough information here for us to actually kind of look into it. So, so we should be able to get the descriptor. So descriptor, find context trace. Is there? Yeah. Finding context. It's been a while since I worked in the front end actually. Descriptor, I think. Declaration to descriptor. Okay, so this is what we want. So what this is going to do is this is for this class. It's going to give me a descriptor, and we can actually, I mean, we can instead just check that way, because at this point, if this check function is getting called, then we are a declaration. So I should be able to call this and get a descriptor out. Value password key. Okay, so if I pass in the declaration here, and if there isn't one, then we're just going to return, because like there's not much we can do at that point. But there should be one, or else the front end hasn't really run. Okay. And so now maybe the better thing to do is like to switch off of the descriptor, and so we can say like a class descriptor, and then here so I mean the descriptor has a lot of information on it. Let's see. Sorry, I'm missing some of the chat. Dev Sue says, I'm only 21 and I started when you were 14. I really like this type of stuff. Compiler plugins and language design. I never did anything towards this, but it's something that I want to try someday. I have a bunch of open source projects. I don't know the quality of the projects and what is my current knowledge to apply for a better job. Currently, I'm the only Android developer in my company, and I fear that not being in a team will be worse for my career. Yeah, I mean, so I sense this comment is maybe about my earlier advice. I want to think more about this, because I hate giving bad advice, but I mean, I think that you can grow a lot as an individual, but it is harder. And having like open source projects and like interacting with others and like I said, like have a mentor, have someone that you learn from and stuff like that, but it doesn't necessarily need to be someone on your team or in your company or anything like that. So like being active in some way, going to meetups can be good. Not everyone has that luxury, but like I think like just constantly learning is always good. And then in your learning, you might find some people that are those people for you, that are the people that you can kind of learn from and see how they work and sort of emulate them and stuff like that. But I mean, like I don't want to tell anyone to like quit their job or anything. I think don't want to give bad advice. So then you say, but in the meanwhile, I don't know if I have knowledge enough for a better Android job, because it's most use sensors like Bluetooth. Do I have any suggestions? I don't know. So I guess one thing is I wouldn't doubt yourself. Like I think people tend to overestimate like other companies and underestimate themselves, or like they tend to think that they don't have the qualifications for a given job or something like that. And I think like an important thing to realize is that especially at big companies, but like just in general, I think when you're hiring, way more important than experience, in my opinion, is like your ability to learn. Like how adaptive are you? How able are you to just go and figure something out? That's like one thing that I really admire in certain people. Is there are some people that they're unafraid to jump in and just learn. And like if there's some entire code base or like new technology or whatever it is, it could be completely unfamiliar to them. But if that is in the way from them getting something done, they will just kind of jump in. And I really admire that in people. And I think that like, a lot of hiring is finding people that know how to learn, and don't think that you won't get a job because you don't have the experience. Think about going and proving that you have the knowledge, like the ability to learn, and jobs should be available to you. And if they're not, then they're looking for the wrong things. Okay, pick one random mobile design and make that happen. Yeah. Leland is like full of wisdom. Well, I'm full of words. I'm not sure how wise they are. Okay. Back to programming. Let's see. This is going to be, I honestly haven't thought enough about the right way to do this analysis. This is going to be sort of the tricky part of this project, and we should think more about that. So Ethan asks, what will the solution for navigation be in Jetpack Compose? Will we embed Compose layouts and fragments using the existing navigation library, or will the team create a Compose router? So right now we're working on an extension to the navigation architecture component that will make it work very well with Compose. And I think that'll be a very good option, and will probably come out soon. I'm also kind of curious what solutions beyond that happen. Like it's possible that in a world where we're less concerned about handling like interop with fragments and activities and stuff like that, that like maybe a different solution will pop out that will be more interesting. But I don't know. I like what I see happening so far in the navigation architecture component, and so I think it'll be a pretty good option. But there are also some other cool ideas out there, like the compose router that I forget his name. Someone from the community built. And I think those are really cool directions to explore. But I worry, like, so navigation is complicated, and like there's a lot that libraries like that will have to do to make sure that they're robust enough to handle all the cases. And I'm not saying that they don't, but just that, like, the earlier the library is, I think the more of those cases that aren't necessarily covered, and so the more people that use it, the more that it's contributed to and stuff like that, they'll get covered. Do I have any benchmarks that you can run to see how much the optimizations you work on improve the performance? Yes. So there's benchmarks in the project that we can run, and I'll probably do that at some later date. And there's some outside of the project as well that we run that are more like integration testy benchmarks that like might run like an entire app and stuff like that. It's like we could look at like, for instance, like Jet News or like some of the samples and run this on those projects and see how much improvement we see. And one of the things to keep in mind is that this optimization is there will be some changes that it causes, like internally in Compose, but in general, the Compose codebase has the stable annotation in a lot of places. And so a lot of these optimizations maybe are being taken advantage of internally, but not externally. And so these optimizations will help like user-land code a lot. And so that's something to consider. Is replacing activities and fragments with something composable considered as a real option? I'm not sure what you mean here, but like, activities and fragments aren't necessarily going away, but I think in a compose only sort of like greenfield application, then you might just have like one activity and it might be almost empty, and you might not use fragments at all and like stuff like this. So I think that you can have architecture that that sort of avoids using activities and fragments in most cases. Okay. So I mean, one thing we can do here is just like, let's try and like opt out in some like really obviously bad cases, I guess. Let's see, descriptor dot what do we have here actually? Sorry, I know that you all can't see this drop down. I'm just looking through the members of the Descriptor here. Oh, it's not it's not a class yet, so I want to see what it is when we smart cast it. Okay, so I can get this unsubstituted member scope, and this gives me some nice things here. So get okay, so I'm gonna just get all of the all name filter. I'll probably just use the defaults here. So children descriptors, and let's play around with that. So Akmir, you asked about like the implicit activity. Not sure if this is what you're getting at, but one thing I've talked about wanting to do is like, I think it'd be really cool if like this was like a full Android app, right? Where you just had like just that. And so this is like a top level main function, and that's like composable, and that just puts you into your app, and you just go from there. I think this would be really cool, but not saying that that'll happen, but I think it'd be really cool, and I'd like to try and make it happen. Yeah, and sky color. So I'm avoiding the auto. Well, I'm not intentionally avoiding the autocomplete, but this is a side effect of how I'm doing the streaming, and unfortunately, it probably won't change just because of a few constraints. But I'll just try and be cognizant of it. Okay, so we can, for instance, go through each child. And so like there's a few things that we'd want to like look at is like, so okay, it's a property descriptor, and child that is var. So like, for instance, if we have a var property, then that's probably not stable then, right? What I kind of want to do is I want to figure out if it has a backing field. Do some logic based on that. There's some interesting cases that we're gonna want to like cover, right? So like, you know, we already talked about these, but one thing that we want is like, for instance, if something has foo by mutable state of, for instance, even though this is a mutable property, we have like it's backed by a delegate, and that delegate is a known stable type. And so in that case, we can then infer that, okay, well, foo then is like a stable property, and because of that, then foo estate will be stable as well. And so that's like an interesting case that we want to make sure that we preserve, and like just seeing that it's a var is not enough. So Danny asks, how do you know what to use when almost all of the compiler APIs are a bit undocumented? Which extension to use? Analysis handler extension, synthetic resolve extension, generation extension, yeah, etc. I don't really have a good answer here, like other than we've just been kind of, you know, walking around in the dark for a long time. So we've some of our other senses have gotten more developed. But yeah, I mean, in general, this project sort of started off with us working in the Kotlin compiler, and like a lot of it is undocumented, or like not really, like not only was it undocumented, but none of our coworkers were familiar with the code base either. And so it's kind of like a frustrating project to get ramped up on, where whenever you're trying to do something new, we don't have like those, like, you know, people sitting around us that have all of this context. Like, you know, the ideal situation is that you have stuff documented. Then the next best is if you have people around that are sort of like walking documentation, and you're able to ask them questions and they'll be able to answer. And then, you know, the worst case is when you have neither of those, and that's kind of the situation we were in. And you know, we've just been sort of gaining context for a long time, and I still feel very lacking in a lot of these things. So so I don't have a good answer for you. Okay, so what I kind of want to do is like this method's gonna get a little bit gnarly here. So let's say determine class stability, and this will give us type stability here. And we'll pass in a class descriptor and probably a binding context. So what we'll do here then is we'll say stability equals determine class stability. We'll pass it the descriptor and the binding context. And I'm just gonna save binding context here. And do that. And so then we can take this code and move that over there. And then we'll basically just, regardless of the result of this, we're just going to record it here. And so then this function becomes like a little bit more sane. And name shadowed. Oh, you know what? I don't even need to get this. It passes it in already. So that was kind of silly. So Kayla Master, you just wouldn't be as comfortable asking JetBrains people like your coworkers because they're not actually coworkers. Well, so like, I guess to be clear, like we do ask JetBrains for help, and we have like some syncs and stuff set up with them. But like in general, it's not the same thing. I mean, so one, there's quite a bit of time difference between like the hours of the day that we work and they work, and in general, we try to figure things out on our own, and then if there's some, really important thing that we need to do and we can't really figure it out or something, then we kind of, it escalates to that level. But usually we'll maybe be able to figure something out in a bit shorter time frame than like our next sync or something like that. So we'll do that. Okay. So Rasco asks, I wasn't here from the beginning. What are you working on? So I'm working on a new compiler optimization in the Compose compiler, and it's called like stability, inference, and propagation. Right now I'm working on the inference piece of that, and there's if you go back to the first episode of this series, which is linked in the chat above, there's like a long explanation of the motivation behind this and everything from that video. So check that out if you're interested. Okay, so basically if it's a var and it has a backing field, then at that point we can like kind of return early, and so then we know it's unstable. And then maybe we can say like otherwise, like if we go through the whole thing and we don't find anything suspicious, then maybe we can say, okay, then it's stable. And so this still isn't complete logic, but this is like maybe a step up of from what we had before. And so let's see if this works in our test here. So go ahead and run that. So Sky Color asks, check function accepts the descriptor as declaration descriptor when descriptor is class descriptor. So class descriptor is a subclass of class descriptor, or of declaration descriptor. So there are lots of types of declarations, like for instance, like function is a declaration, class is a declaration, stuff like that. And so right now I'm just focused on the class declaration, and then we'll play around more with that as time goes on. One thing I'm worried about, okay, so that worked, which is good. So this returned unstable in the case that we had laid out. So one thing I'm a little bit worried about at the moment is like, how do we, I don't know what the ordering guarantees of like this is. So if I, like if inside of this function I decide that I'm going to check to see what the element stability of something else is, I don't know if this will have run on that yet. I'm not really sure what to do about that, because this isn't like a, yeah, I'm not really sure how to solve that. I know that like there's there's basically some checking in the type system that kind of allows for this type of stuff. So like you can, what I can basically do is I can sort of, you know, save a result like at the end of this function, right? Like with this, and then like here I can check to see if I'm like currently being called, or if I, you know, asked for like as I'm checking, I can then like just call myself and say, you know, I'm gonna check this one as well, and then if it gets called twice, it'll just return the previous result. So we might have to do something like that. And I'm wondering if descriptor is actually the better thing to use here. Like, so instead of recording this on the declaration, maybe maybe I should record it on the descriptor, because I'll end up getting like child descriptors here, and so then I can go and I can essentially run this analysis on other descriptors and just kind of keep doing that recursively. So I don't know, that might be the right way to do this. And so maybe I can just call determine class stability. So for instance, if I go here, let's create a declaration descriptor. So I could create a writable slice like that, and then what I could do is I could check here. So descriptor. And then here, like maybe I don't even use the declaration here. So determine declaration stability. And then this looks like this. Stability. So I can do that. So then here I can do this for like the whole thing. What? Okay. If stability is not null, then return stability, else. Descriptor. Actually, I'm going to keep that. So else, I need else. Okay, so if we've already found the stability, then I can just return it. And if it's not known, then what I can do is I can do some stuff here, right? And then I'm gonna save it. I need a binding trace actually. Right? Record, I don't have that. No, I need to record it on the trace. So we're gonna change this to binding trace. Actually, we'll just call it trace. And then I'm going to say trace.record. And then we're going to record the declaration descriptor here. And then we'll record the newfound stability and then return that. Let's see. So we'll have to need to handle, or let's say unhandled declaration descriptor. That'll tell us something. And so when it's a class descriptor, we're going to say return, and then I'm going to change this to a trace, binding trace. And so here we'll pass in the descriptor and the trace, and then that should be enough. Okay, this is starting to look somewhat sane. I don't know. And so then here, I wonder if we don't. So yeah, so maybe element type stability is just like not really the right thing. So then when we call check, maybe we just want to say determine declaration stability, and we'll pass in the descriptor and the trace, and that's like it. We're done at that point. And then we'll need to update our test to look at this instead of the element thing. And then this needs to be class stability. Okay. All right. So let's update our test real quick. So in this case, once we're at the class, we're at a declaration. And we actually might even want to change it to declaration, and then we'll say descriptor, and that'll be the binding context declaration to descriptor. Binding context declaration to descriptor. Okay. Otherwise, so if the descriptor is not there, we can probably just fail. I think that shouldn't happen. Not found. And then we can say, okay, stability, and then this is going to be declaration stability. based on the descriptor. And now we should be good. What is this telling me? Oh, I need to pass the node. Okay. Let's see if that works. Catch up on some comments here. Are you describing like it's a recursive call, but you have to store the result if the same arguments are passed in again? How would the syntax for compose be worse without any compiler plugin? Yeah, so SkyColor, I'm just trying to, I'll need to handle, well, one, I want to make sure that basically the function's like memoized essentially. So it'll, if the same thing gets passed in, it'll not do the work of figuring it out more than once. But the other thing I'll need to make sure happens, which I haven't yet, is like circular references, and I'll need to figure out how to handle that. Like you can have circular references in the type system, and we'll need to decide how to what we want to do in those cases. And as it's written right now, it'll just it'll probably just create an infinite loop. So Caleb asks, how would the syntax for compose be worse without any compiler plugin? So yeah, maybe I can show that a little bit. Basically, if you want to think about it, example. So let's just say we've got two composable functions, right? And like if we didn't have a compiler plugin, the question would be like, I mean, in addition to some other things we do, like how would like why wouldn't this just work, right? Like it's certainly valid Kotlin, like, you know, without the annotation or whatever. But at this point, then it's just executing the function and nothing's really being done with the result. So the way that other frameworks like do this is like, okay, well, like the function needs to return something. Like right now, the execution of a composable function communicates with the runtime because of the things that the compiler generates. But if it doesn't, then like the kind of sane way to do that is like you return something. So like, let's say we'll call that element, right? And so then you can say, okay, well now all composable function, like all of the like UI widget functions, like return this like element type, right? And you know, whatever that is. And so you can do that, but now there's more questions, right? How does this get called for the first time? And if we want to update the state of things, so like if some state changes and we want to update the UI, how do we just update part of the UI? And so like we don't know what A is or like what B, like you just called B. There's nothing being recorded anywhere. Like all that's happening is like the result of B is happening. And so then the way that like other frameworks sort of solve this is like you essentially like pass in B to like, you know, some intermediate function, you know, and so you can say, okay, I'm returning an element, and so maybe, you know, like maybe H is something that returns an element. So, you know, this does something, and so then like you basically have to invent a call convention that's not actually calling the function. And this doesn't, you know, it doesn't really get any better if you have like if you use classes instead of functions. So, you know, let's just say we've got some class A or whatever, and then it, you know, it implements component, you know, and then it's got like some compose function, and whatever, and so then this then returns, you know, B. But again, like that's also not what we want. So like let's say, like even if B was a like if it was a component here, and then it, you know, it returned an element, like there's not, like you can't really get around the need to create a call convention. And so that, you know, there's going to be something like H here that essentially says, here's the thing I want to call, but you do the calling for me. And then also record the necessary information, like otherwise to like update it if you need to, and stuff like that. And so essentially, like that's the dance that the compiler gets around. And you know, this was made what was I gonna say? Like how this works, it like the type system can kind of get in your way here unless you have a very powerful type system, and Kotlin's type system isn't really quite powerful enough to like represent like this H function. You know, it's really hard to define this and have it be type safe at the same time, and so there's you know, there's a lot of complications there. But so I mean, I don't know, maybe that kind of gives you an idea of like what kind of things the compiler plugin is helping you with. Okay, so what went wrong here? So okay, well yeah, so we wrote an error that we hit. So that happened here. So let's say is function descriptor. Let's just, like, again, not correct code, but we're just kind of getting us in like a happier place. So let's just return stable for that. And so basically now we've got class descriptors, function descriptors, and property descriptors. And so we can maybe define something like this, right? Property descriptor. And this might look like that. So this probably isn't entirely correct. Like this is not exactly what we want to do, but this will kind of give us a good starting framework, I think. So basically we can say if determine actually, so this would be interesting. So for each child, we can say stability equals determine. We can end up calling this again, and we'll pass the child here, and that'll end up being memoized, and then we can say, you know, if stability is not stable, then return stability to unstable. Something like that. So this will get us kind of started here. And then we'll say this descriptor See how that works. You know, I start every time I start a stream, I like check my camera to see what the like exposure levels are at and stuff, and it doesn't seem blown out when I start. And then like by the end of the stream, my room is like bright enough that I feel like it's just like a background of white. Not sure how to like change it midstream or anything. Can't really do that very easily. Okay, so our test passed here, which is good. So for reference, we're kind of correctly handling these two cases. We're gonna need to get way more advanced than this, but this is kind of a neat start. Yeah, at least it's just this nice little corner in the bottom right most of the time. Yeah, I mean, I don't have it set to auto expose. I have it set with a particular exposure level. Part of the problem is that like the lens I have it set to f1.4, and so it just lets in a ton of light. Like right now, my ISO is set to 100, which is as low as it can go. So I would need to change the shutter speed to make it darker, but gotta have that bokeh, you know. It is a prime lens, yeah. It's the Sigma 16mm f1.4. Gotta look good while working. That's right. Okay. So trying to think what we want to do next. I kind of want to get like the full pipeline, you know. Like I can continue to improve the inference here, but like I kind of want to get everything connected so that like wired up so that it like works, and then we can just improve it slowly after that. And so I think what I want to do is like have the stability here, like figure out how to pipe that to the back end without using descriptors. And so I think we're gonna do that. With one of these extension points. Where is it? So I think this type resolution interceptor might help us out. So let's add that. Or I wanted this, not that. Does it have default? Yeah, I guess it has default implementations. So, so I guess my current thinking is that I'm gonna try and add an annotation to the types of certain expressions. You know what? I mean, so maybe call checker. Like, so one thing I could do is I could use call checker here, because the only the only thing, I only really need to know the stability of expressions that are passed into a call, a composable call. And so maybe if I do it that way, I could just annotate the types. I don't know. Have I considered blinds? So actually I have my blinds closed right now. So I think the problem is that my blinds let in light, so they're not like you know, what do you call them, the blinds that like are completely opaque. And so I mean maybe I should get different blinds, but in general it's like a really nice aesthetic normally, just like not for the camera. Yeah, blackout blinds, blackout curtains. Yeah. So I don't know, maybe I'll look into something like that. But in general, I like the way it looks, you know, when you're not looking at me through my camera. So we'll see. So that it's dark at this time, yeah. Yeah, I mean, I could stream later in the day, but you know, the problem is I don't want to stream too much off of work hours, because I want to consider this kind of part of my work. Put a spotlight. Yeah, it's a nice office. I mean, so I have lights like in front of me to you know, to make the lighting good, but it's still relative to the sun. They're pretty weak still. So all right, I don't think we want to do anything here, so I don't think I need to implement that. But intercept type, I kind of want to see when this gets called, because it's kind of an interesting extension point. I'm not really sure. I think we actually made this extension point, but so let's see if I go to the tests. If I just do this, I kind of want to see when that extension point gets called, if at all. Oh, and I probably need to add it again. Yeah, type resolution interceptor. So all right, whatever. So in here, I think I want to create one of these. And then pass it into each one. So I'll do that and then do this. Let me see what that does. And I guess I need to figure out what to do here. Weird. Okay. Oh no, I wanted to debug. Same issue. So I guess, oh, I just do that. This is weird. I don't really know what this is doing, but all right. This is like the jankiest thing I've ever seen. I don't know. That just weirds me out completely. So let's see if this builds now. Check resolved call. Oh, I added call checker here. We don't want to do that yet. The jank is how you pay for custom compiler API JetBrains doesn't want others to use. Yeah, that's true. It's valid. But even beyond that, right? Because I mean, I think the opt-in annotation, that's like enough. It's like, okay, internal non-stable extension points. Like, I get it. But like, we're referencing something that's not public, invisible reference. I've never even seen this. I don't know. That's just weird to me. I don't even know how that works. Oh man, this compile time. I don't know why this one's so bad. So it built. That's good. So I guess the question is then will this hit? Because I'm not sure it will, because it's like we're intercepting a type, but they're like the code that we're type checking, there's like basically no expressions. Yeah, so that didn't even hit. But if we, for instance, add like so let's do something like this. now I think it'll hit like for this expression or something. Find out. Waiting times seriously mess up my productivity. If I have to wait more than like 5 seconds, my mind will wander. Yeah, it's very true. I mean, so there's actually, I remember I used to work on like an infrastructure team at Airbnb, and one of the things we talked about was like there's interesting repercussions to different build times, and there's basically if you have a build time that's like longer that like, you know, if it's like shorter than 3 minutes, that's awesome. And if it's longer than 3 minutes, that's when you start to get into like real bad territory. But you actually get better if it like hits like 30 minutes or something, or like 40 minutes. Like if you get build times that are so long that the only sane thing to do is to hit build and then switch context entirely and go do something else. And so it's like you kind of want your build times to either be short enough that like people are able to like iterate continuously, or long enough that they won't even try. And then they'll go and do something else, which like if that's how bad it is, then it's like terrible, but it's like kind of true. And there are some, you know, we had I remember there was one case where like we started measuring our build times, and I won't mention all the specifics, but like we started realizing that like the build time of this particular project was increasing by like 45 seconds every week. And like we started plotting it out, and we just like it was just like linearly increasing every week. And then we were like, oh crap, we really this is like an all hands on deck situation. We're like gonna drive our company into the ground. So okay, what happened? Sleep 37 minutes. What is yeah, oh yeah, deprecated. Yeah, it's marked as deprecated areas. Error. Are you saying that have I ever done like thread.sleep for like 37 minutes just to like make the build more make the build slower to get people to go and do something else? That would be bad. What do we got here? Okay, so local variable descriptor. So realistically, like we probably want to kind of cancel, like there's probably some declarations like a local variable where we might not even want to well, that's not necessarily true, but anyway, let's just do that for now. Yeah, we just ensure that we're exactly at 30 minutes. That would be a hard PR to land. Can you imagine trying to convince people that that was a good idea? Here's our build infrastructure. I'm inserting some thread.sleeps here. All right, when I get this set up, I'm probably gonna end the stream there. I think we've gone, what are we at now? 2 hours, 16 minutes. but I'm pretty happy with the direction so far. Yeah, productivity improvement, just immediate rubber stamp. Just bury it in like some 10,000 line PR, and then no one will actually read it. All right. So our test passed, but we're still not getting this extension called, which honestly I'm not even sure that this extension works, so maybe that's what we're learning here. But I was trying to figure out when this got called. I think maybe we so we should find out. I see. So this is really only going to intercept lambdas. So this isn't really a viable extension point for us to use, which is fine. We'll find a different way, I think. So I'm gonna not do that. I think maybe the call checker is the right way to do this. And where do we go? So we'll remove this again and remove that, and then this janky stuff. Thank God. Okay. So I think the strategy that I'll take, and actually I want to check what this additional type checker thing is, but so one of these two extension points I think will give us what we want, but we'll have to decide what the best approach is. And I'm going to start trying to think a little bit more about what metadata we need to store, and how to get that from the back end. I'm not sure if I'll end up working on this before Friday, which is the next stream, but I might. So let's see. You don't want anyone to see the bad code. Gotta make a reasonable PR, and once it's approved, force push. Yeah. Although hopefully your infrastructure avoids marking a force push as approved. But yeah, okay. So I'm pretty happy with where we got. That's gonna be it for today. And so thanks everyone for tuning in, and I'll see you on Friday. Or, if you want to reach out on Twitter or something, say hi, go for it. But yeah, appreciate you all coming by. All right, cheers.